In this video, we're going to look at the normal curve, z-scores, also called z-values or standard scores. A little bit of probability. We'll go into more detail on probability in the next video. I just want to lay the foundation for some things you need to know. Some of these you already may know if you're looking at this video, but just in case, a little overview. So let me first look at what a z-score, a z-value, or a standard score is. So here's the definition. If x is a value from a normal distribution with mean x bar, so that represents the average of the distribution. It could be scores from a test or IQ test or whatever. And standard deviation s. So again, keep in mind that the standard deviation measures the extent to which scores in a distribution deviate from the mean. So the larger the standard deviation, the more spread out the scores are. So if a teacher, for example, gives a test and everybody scores exactly a 70 on the test, then obviously the average is going to be 70 and the standard deviation is going to be 0 because there's no deviation. Everybody scored the same, right? So generally, a teacher prefers the standard deviation to be kind of small, somewhere in the neighborhood of 10 or so. If you have a standard deviation of, say, 25, then you can see if there's a big spread in the scores. A lot of people flunked, some people passed, and so forth. But we want generally the deviation to stay kind of small, if you're a teacher, that is. So in this case, then, the z-score, or the standard score, is given by this formula. So we take the value of the score, subtract the mean, and divide by the standard deviation. So if a person, let's say a teacher gave a test, and like I said, the average was 70, and one student, say, scored 80. 80 minus 70 is 10. Divide by 10. Let's say the standard deviation on that test was 10. 10 divided by 10 is 1. So that student scored 1 standard deviation above the mean. Let's say another person, say, scored 90. 90 minus 70 is 20 divided by 10 is 2. And that person scored better, 2 standard deviations above the mean. Now let's say somebody made a 60. 70 minus, or 60 minus 70 rather, is a negative 10 divided by 10. That's negative 1. So that student scored negative 1 standard deviations below the mean. Okay. A person with a 50, that's 50 minus 70 is negative 20 divided by 10, that's negative 2. So that person scored 2 standard deviations below the mean. So a positive z-value means you scored above the mean. A negative z-value or standard score means you scored below the mean. So obviously you want to be above the mean. Okay, the higher you are, the better the score is. Okay. Another thing about probability, so again, just to remind you that probability is always a number between 0 and 1, including 0 and 1. So if I say the probability of rain is 0.2, then the probability that it doesn't rain is 0.8. The total probability of those types of events always has to add up to 1. So in general, if you have a probability model, the total probability, that is the probability, all the possible events of that model have to add up to 1. For example, in a rolling a die, you have 6 outcomes. You can either get a 1, a 2, a 3, a 4, a 5, or a 6. So the probability of getting a 1 is 1 out of the total, which is 6. The probability of a 2 is 1 over 6. A 3, 1 over 6. A 4, 1 over 6. A 5, 1 over 6. A 6, 1 over 6. You add those up and you get a 1. Okay, so again, generally probability of some event occurring is always greater than or equal to 0, less than or equal to 1. So if the probability is 1, that event is certain to occur. If the probability of something occurring is 0, that has no chance of occurring. But in general, the closer the probability is to 1, the more likely that event will occur. The closer the probability is to 0, the less likely that event will occur. Now we talk about the normal curve. So what that means, if we take a large sample of the population, so let's suppose we take a large sample of the population and we give those people an IQ test. And then we plot the frequency. Okay. Generally, intelligence is normally distributed. So what that means is that if you plot the frequencies on a graph, we're going to get something that resembles what is called a bell-shaped curve. So again, kind of like a parabola opening downward, but on the right it approaches the horizontal axis. On the left side it approaches the axis again. Okay, so this value here in the middle, which they use a Greek letter mu, it represents the mean. So let's suppose that in this particular case we gave an IQ test and the mean or the average on that test was 100. Okay, let's suppose sigma, this symbol here, that's the standard deviation. Instead of S, they're using sigma here. So this is mu, and then over here to the right is mu plus 1, so that's 1 standard deviation above the mean, and then mu plus 2 sigma, 2 standard deviations above, and then mu plus 3 sigma, 3 standard deviations above. And then in the same way, on the left side, mu minus sigma, 1 standard deviation below the mean, mu minus 2 sigma, 2 standard deviations below the mean, and so forth. Okay. Notice the symmetry of the curve. So notice between on the right side, between the mean and 1 standard deviation, we have 34.1%. On the left side, between the mu and 1 standard deviation below the mean, we have 34.1. Now, if I were to add these percentages that I have here, I'm going to get 99 point something. In theory, it's going to be 100%. Okay. The further I go, remember this curve approaches the axis, the horizontal axis, as it goes to infinity on the right and on the left. These percentages are going to add up to 100%. Now we can also look at these as probabilities. Okay, so for example, I can look at this and say, okay, if I give an IQ test, what's the probability that any person selected at random from that distribution of scores is going to score between the mean and 1 standard deviation above the mean. In other words, between mu and mu plus sigma, and that would be 34.1%. Okay. And again, if I select one person at random, what's the probability or percent that person will score between mu minus 1 sigma and mu plus 1 sigma? In other words, what is the percent of people that would score within 1 standard deviation of the mean? Okay, so that's talking about this blue area right here. You add those percentages, and that's 68.2%. Okay, now this is always going to be true. These percentages are always going to stay fixed, regardless of what the mean is or what the standard deviation is, as long as it's normally distributed. The curve or the shape of this curve is going to look the same. It might be a little bit taller, a little bit lower here. It might be a little bit more spread out. But in general, all these percentages will always add up to 100% in theory anyway. Or if we're talking about probability, they're going to add up to 1. Okay, total probability will be 1. Okay, so we can look at these as percentages of something occurring, percents of something occurring. We can look at these as probabilities. We can look at this as area. Okay, what's the area under the curve? Again, it would be 100 or 100%. What's the probability under this curve? We normally would say 1. Probability is usually a number between 0 and 1. We can use percents. So we say the probability of rain is 60%, for example. And then the probability is 0.6 or 0.60. But this is always going to stay the same. Okay, so I can use this normal curve to compute probabilities or percents. Okay, so for example, if I say we gave an IQ test to a randomly selected group of people, say 1,000, how many scored between the mean and one standard deviation above the mean? So how many persons scored in this group right here, in this area right here? And of course it'd be 34.1%. So multiply that times 1,000 and we get 341. So of the 1,000, 341 would score between the mean and one standard deviation above the mean. So the answer that you give then is going to depend on what they're asking. Sometimes they're going to be asking you the number of people that scored in a certain range. Sometimes they're going to ask you for a probability. Okay, but these are all going to be the same. So you can change these percentages to decimals and give the answer in terms of a probability. Now, if I were to take these values that I have plotted on the horizontal axis here, okay, the mu plus 1 sigma and so forth. If I want to compute the z-values for each of these, okay, so remember the formula is you subtract the mean, and divide by the standard deviation. Okay, so that would be mu minus mu would be 0 divided by the standard deviation. This mu then would be a 0. Okay, so if I were to do that and replot this, this is what I'm going to get. Well, I'll take it back. This is what it looks like if I put in the actual values. Okay, so this is what it looks like if I actually give you the value of mu and the standard deviation. So let's suppose that in the IQ test the mean was 100, like we said, and the standard deviation was 15. Okay, so 100 add 15, we get 115. 115 add 15, we get 130. And then subtract 15, one standard deviation below would be a score of 85. 2 standard deviations below, subtract 15 again, we get 70. Now the percentages are still going to stay the same. Okay, so over here on the far right, to the right of 130, remember that value was approximately 2.15%. So approximately 2.15% of the distribution, assuming we had to take a random sample, would score higher than 130. Then on the far left over here, we have, again, because of the symmetry, we have another 2.15% which score less than 70. So basically, those people that score higher than 130, those would be your geniuses, very smart. And the ones over here on the far left, below 70, would be the ones that are not so gifted. Now, the average is considered within one standard deviation of the mean. So people that scored within 85, between 85 and 115 would be considered average. So if the average score on the IQ test is 100, if you score within between 85 and say 115, that's considered average. Okay, that's the average population. So again, that's 68%. And notice 95%, most of them would score within 2 standard deviations. Okay, 2 above and 2 below. So all of this area right here, that's 95%. Okay, so 95% of those people tested, or if we tested 1,000, that would be 950 would score between 70 and 130. Now again, we can look at that as a probability, and I ask, okay, what's the probability that a person taking this IQ test would score between 70 and 130? In that case, your answer would be, say, 0.95. Okay, because generally we give the probability in terms of a number between 0 and 1. You can use fractions, also percents, but generally it's a number between 0 and 1, whether it's a fraction or a decimal. Okay, now let me do what I said. If I go ahead and subtract the mean from each of these values. So 100 minus 100 divided by the standard deviation would give me 0. So this 100 there would represent the mean, but it would be a 0. It would correspond to a 0. And I'll go into more detail later. Okay, over here, the 115 minus 100 is 15 divided by 15. This would then become a 1. Okay, so all I'm doing is I'm writing these scores in terms of z-values. 130 minus 100 is 30 divided by the standard deviation of this test is 15. This then would be a 2. Okay, and I would continue. Okay, and then on the other side, 85 minus 100 would give me minus 15 divided by 15. This then would be a negative 1. This 85 would correspond to a negative 1. And then the 70 then would correspond to a negative 2. That's 70 minus 100. Divided by 15. So it's negative 30 divided by 15, negative 2. So we would have those z-values. On the far right, in the middle we start 0, 1, and 2. And then on the left, this would be negative 1, negative 2, and it continues and so forth. Okay. Now that graph again has the same percentages, except I have it in terms of z-values. And the reason I want to do that is because it's easier to work some of the problems that we'll be doing. Okay, so here's the same thing in terms of the z-values. Okay, so I wrote it in terms of z-values. So notice the percentages are the same, except now this one is written in terms of decimal, but it's the same thing. 0.3413 or 34.13% if you want to look at those as percents. Okay. But the same thing. You can see that still the percentage of those that scored within 1 standard deviation of the mean, that's in this area right here, would be 0.3413 plus 0.3413, or 0.6826 would be the probability. The percent would be 68.26. Okay. So we could actually use this graph to compute probabilities and so forth, or percents and so forth, but it's only going to work if we're dealing with problems where the z-values are integers. Notice here it's nice integers. But what happens if we want to find the probability that a person scored within 1.2 standard deviations of the mean? Then we can't use this. Okay, so the alternative would be to use either a table or a calculator. So I will go over both. I'll start off using the table, and then in a later video I'm going to look at the same types of problems and show you how to do it on a graphing calculator. So let me go back over here. There's a definition of a z-score or z-value or standard score. And then over here, this is what we're going to do here. Just find the percent of the total population that is found between the two given z-scores or z-values. Find the percent of the total population that is found between the two given z-scores. Okay, so in this case, I want to know then the percent of the population that is between the mean and 1.4. And notice the z-value is positive, so it's we're talking about 1.4 standard deviations above the mean. So how many scored between the mean and 1.4 standard deviations above the mean? And I have the answer in parentheses, but I'm going to show you how to get the answer first from a table. Okay. Because I can't use the graph that we looked at, because again the z-value is not an integer, it's decimal here. So like I said, first method to do this is using the table. Okay, so here's the table. So notice what the instructions say. For a particular value, this table gives the percent of scores between the mean and the z-value of a normally distributed random sample. So again, for this type of situation to work in these types of problems, you do have to have distributions that are normally distributed. That means they have to form a normal curve. So examples of those would be intelligence, IQ scores, heights of people, weights, okay? So given that, here's what the table does. Okay, so you can see from the diagram. So basically what the table is giving you this area from the mean, so right here, to the z-value. Okay. So all you're going to do is basically look up the z-value. So for example, let's say we wanted to find the area from the mean to, say, 0.1. 0.1, somewhere in here, 0.1 standard deviation. So we look at the table. Okay, so let's look at first under the z column, find 0.1. There it is. So it's 0.1. So since I don't have anything else after the 1, I would have to look into the first column. So that I would find 0.0398. So in that case, the answer I would give would be 0.0398. If it was asking me for a probability, if it's asking me for a percent, then I would give 3.98%. Okay, or if it's asking me for the number of people that scored in that range, then I would take that value and multiply it times whatever the number was. Okay, if it was 1,000, I would multiply that by 1,000, and I would get say 39.8. Now, if the z-value was 0.12, okay, then I would again still find the 0.1, and then I would have to go over to the third column right there, and that would give me 0.12, which would be 0.0478. Okay, to 4 places, and again, if it's a percent, I would give 4.78% and so forth. Okay, that's the way the table works. Now I want you to keep in mind that let's suppose that it said the z-value was a negative 0.1. Okay, so now we're on the left side. So let's say the negative 0.1 is over here. Okay. Well, again, because of the symmetry, it's going to be the same answer as if it was a 0.1. So if it's a negative and you want the area between the mean and the value, just ignore the negative, and the answer would be the same, 0.0398 or 3.98%. Okay, so keep that in mind. Because of the symmetry, you can ignore the negative. Okay, so let's go back. Find the percent of total population that is found between the two given z-values. So now here we're looking at z equal 1.4. Okay, so we go to the table. Here we go under the z column and find the 1.4. Okay, 1.4, there it is. And in this case, because there's nothing after the 4, we look into the first column, and that's be 0.41, 0.4192. 0.4192. Okay, so I have the answer there in parentheses. So since it's asking you for a percent here, then you would say the answer then would be 41.92%. Round off if it asks you to round off, but I just give 41.92%. Now, if it asks you for the probability that a certain score is within the mean and 1.4, then the probability would be, I would just give it as 0.4192. Okay. Okay, the next one, I want to find the percent of the total population that is found between the two given z-values. In this case, the mean and a negative 2.22. Again, remember what I said, because it's negative, you can ignore it and just look at the positive on the curve. So it's 2.22. So again, we have to go to the third column here, 0.02. So 2.22 would be over here, and that would be a 0.4868. 0.4868. Because it's asking for the percent, we would give it as, say, 48.68%. 48.68%. Okay. Now, in the next one, we want to find the percent of the total population. Okay. So again, in this particular case, this could represent. They could ask you, what is the probability that a person scored within 1.4 standard deviations of the mean. So you could give it a probability. But in terms of finding it, again, we have negative 1.4 and a 1.4. So again, what we would do here is we would find the percent or area or probability, whatever you're looking for, between 0 and 1.4, between 0 and 1.4. And we found it in part 1. In the first problem, it was 0.4192. And then we find the area between the mean and a negative 1.4, okay, from the table. Ignore the negative and find it. And then we just add the two values. But in this case, we don't have to look it up because it's the same area, remember? Because of the symmetry, 1.4 and negative 1.4, it's the same answer. So all we would do is double the 0.4192, and we would get 0.8384. Okay. So again, because it's asking you for percent, you would say the percent of the total population that is found between the two given z values, in this case between negative 1.4 and 1.4, is 83.84%. 83.84%. Or if it's asking for a probability, I would give it as 0.8384. And of course, you can round off accordingly. Now, this video kind of sets the foundation for the next couple of videos that I'll be doing on normal curve, and we'll focus more on probability problems in the next video. And then, like I said, follow-up video, I will have another way to do this using your graphing calculator. But at this point, this concludes the video. And again, as usual, if you have any questions or concerns, please post them. Any ideas on future videos, again, please post those. And again, if you subscribe to my channel, I will consider your requests. And again, thank you for watching, and we'll see you in the next video.